Hello friend, welcome back. So today I am going to discuss this NodeMCU ESP8266 development kit named as ESP12 and with DHT11 sensor. So this is the ESP12, that is the NodeMCU ESP8266 development kit, and I will be using only this sensor from this particular blink board, and this is connected through USB to my laptop, and only three connection will go here, and that I will show you. Only like one is that at GPIO 14 from somewhere here, so I will show you that. Other thing, apart from that, you will see that I have provided that link to purchase both of these two on the right side of my screen. You will notice that later. And the this post is to understand the DHT11 sensor working with NodeMCU board. It will also help to understand the pseudo code required. I am using DHT11 mounted in blink board. Please subscribe to YouTube channel Embedkari for further discussion on embedded systems. Set requirement, as I told you, is NodeMCU board plus Blink board, nothing else. And what is NodeMCU? So this NodeMCU is known as Node Microcontroller Unit. And basically the NodeMCU is open source software and hardware development environment that is built around a very inexpensive system on chip SoC called ESP8266. The ESP8266, designed and manufactured by Express Systems, contains all crucial elements of the modern computer such as CPU, RAM, networking using Wi-Fi, and even a modern operating system and SDK. So this complete definition you will find here, and at that IBM side, and also you will see that pinout here, and I am interested today only at D5, that is that GPIO 14, and others, you know, that VIN and other thing will be anyway that will be connected directly ground and power supply from here, and that I will discuss this particular board. And other thing here, documentation link I have provided for this board, that NodeMCU documentation, and from here you will see that NodeMCU is open source. This Lua based firmware. In fact, I mentioned here also, this is an open source Lua based firmware for ESP8266 Wi-Fi SoC from SPC, and uses an unmodule flash based SPIP file system, and NodeMCU is implemented in C and is layered on this non-OS SDK. So this is what it is mentioning in that IBM one also. Okay, and one thing here, the difference modern operating system and SDK, that operating system I'm not seen yet on this. I am not using out that level, and I'm not sure how much memory and all that that is. And but as per the documentation here, it says like uh, if we read at that actual documentation from there, here you can say non-OSST key. Okay, so that I am not interested right now, operating system related thing, that I need to double check, and not that point of discussion for today anyway, that is not needed, and I'm not sure like kind of memory it may be supporting that. And probably that other devices will be supporting, the higher end devices may be supporting from the same ESP series. So that's why cannot deny also that. And what is DHT11? DHT11 is a low cost humidity and temperature sensor which generates calibrated digital output. This is important, calibrated digital output, and very cheap. And this sensor, so digital output means we don't need any analog reading and all that. This sensor, it is sensor, doesn't mean that we need analog reading. And this sensor includes a resistive type humidity measurement component. Based on the change in the resistance, it will measure that humidity, that will be relative humidity, and also that based on the negative temperature coefficient of NTC temperature measurement, that is also same the electrical property of the resistance. It will measure the temperature, and most other humidity sensor use capacity measurements also to determine the amount of moisture in the air. So those also, like capacity is also based on the electrical property, uh, you know, the kind of LCR kind of circuit. So one should check all the parameters such as operating temperature range, or in which range it will work, and voltage required, current required, accuracy and resolution in the data sheet of particular DHT11 device vendor. I provided data sheet of one particular device as reference. It provides relative humidity of accuracy plus minus 5% and temperature measurement accuracy plus minus 2 degrees centigrade. So I opened one of that faulty DHT11 sensor for just for inspection. So from the front side, I can see IC here, and this one IC, and one is small, you know, component here, and back side is component sensor. And connection diagram is very simple, as I told you. Only 3 connections are required. So one, this is anyway that power supply. I will say this is a VCC. So depending on that voltage provided by that particular, you know, it range 3.3 to 5 volt. So it can be connected to this. And other thing is like apart from the VCC, it is like ground. This is a ground, and this is not connected, this third pin. And this is the actual second is the digital output from the sensor and input to the GPIO 14 pin of that ESP8266 and pulled up to the VCC. And this basically integrate the data of both humidity and temperature in the digital signal. And since I am using DHT11 mounted in Blink board, so I have to only plug in the NodeMCU board to the Blink board and connect USB cable to the PC or Arduino installed. That's it. So just plug in there like this, just plug in there and connect, and nothing else is needed. All the pull up, everything is being taken care in that PC. And okay, so this is final, you know. And so how data transmission starts? So MCU sends a start signal to start the communication, and this wakes up the sensor from sleep mode, and sensor sends a response followed by a burst of 40 bits data and goes to the sleep mode again. So how it is like that? mm, let me try to show you this. So MCU send this particular signal, that is normally VCC, and that is called, we'll say, ideal, and goes low, and based on this data sheet it is say 18 millisecond low. So and then it comes high, the MCU makes it high, and then again it is 20 to 40 microsecond. Basically it will remain high, and ideally what will happen, that MCU will make here the digital pin as output, and then it will send that 0 data there, and for this duration, and after that it will make simply it as input. So then it will become high, and then because pull up is also there, and then this side DHT. So this particular thing, that DHT after wakes up, that DHT11, it will pull it low as a acknowledgement sign, and again after 80 microsecond it will pull up high for 80 microsecond. So this is the acknowledgement kind of thing, that this time for CPU to get ready to receive the data, and then data will start 40 bit, and then again it will go to the ideal state. So this is that way communication happens, and here it is clear the timing, high, low, everything. After that, in the data encoding in terms of signal, so you can say data 0 is encoded like this, means if it is 50 microsecond low, and then it will be 26 to 28 microsecond high. So that is 0, and 1 is encoded like, if it is 50 microsecond it has to be there, and approximately like 70 microsecond it has to be high. So that is that 1. So there is a clear difference between 0 and 1, and if you can see this like clearly that between these two, you can see the difference here, 1, and now it's clear, this is the 1 and this is the 0. Okay, and one thing, okay, let me further show you that. So finally this is the complete picture, means that this is that start signal, this is the acknowledgement, and then the data, that you can see clearly here from this from MCU side, then it goes slow, then come high, then it becomes output this thing data. So it may be depending on the data, whatever is the data, it's like that only. And then after this the data format consists of the 5 bytes, that is 40 bits. So first 8 bit will be like integral of the relative humidity, and then second will be this thing decimal of relative humidity, then temperature, then same integral part, decimal part, and finally checksum, that is the parity based checksum to check if any error. And relative humidity, I have provided some link here if you are interested to know further that how that moisture, this link, you can go there for the detail about that how, what is that in terms of relative humidity, the amount of moisture present in the air at a particular temperature, and what is expected. That is a relative kind of approach. And the pseudocode, so based on that, whatever we understood from that, our one wire signal start send start pulse, so you will write always pseudocode. After that you can easily code it whatever language. And pseudocode, basically it is platform independent. So if it is it will be, you may implement it any microcontroller. Only thing you have to implement that in particular C assembly or whatever language. So send the start pulse, then pin mode will be output, pin data is 0, and this is the way start pulse it will send. Then delay for the low duration, then it will make it input, then delay for 40 microsecond, 20 to 40 microsecond it will, and then by the time it will other side, then it will wait for this acknowledgement high duration, and then wait for acknowledgement low duration. So basically the same thing here. It should be like wait for this duration and then wait for let me first this thing. So after this it will wait for this duration and then this duration. Okay, then finally it should be low first, then high, and okay, and then read that 40 bits in buffer after that, and check data received and with the checksum, and then it will verify that, and then check that status flag. So basically that once it has whenever it is monitoring whether it is a high or low, so this is basically based on the acknowledgement. It will go first low, so it should be corrected, then it will be high, and based on that whatever pseudocode you write, and then after that during this time also, if it is not getting acknowledgement, then timeout provision should be there. Here also timeout provision should be there, because we know data 0, data 1, that how much maximum low or high is expected. Similarly, once if there is no timeout, then it means it is okay in terms of no timeout, then it will check the data with the checksum. If there is no parity error, then it is okay in terms of parity error also. So finally the status flag is okay, then it will read that data from that all the 40 bits from the data buffer, and parse that according to your humidity and temperature, and act accordingly. So this is that basically GIF file I created from that lab experiment, and here you can see that COM port and all those kind of settings are there, and whatever that board info, and then serial monitor. In the serial monitor, then that it will start sending the data. Okay, so reference, as I told you, I have provided the data sheet, and as well as I have provided the documentation. Okay, and please subscribe to YouTube channel Embedkari for additional information, and for that other thing you can go to the link of the open source I have provided there. And thanks for your time, and let me show you again this thing. Okay, thanks.